Okay, I'm going to try to keep this video pretty brief. Quick reminder of what arithmetic and geometric sequences are. So an arithmetic sequence is just a sequence of numbers that have a common difference, which means that here's your list of numbers, and if you do repeated subtraction, so take the second term, subtract the first term, take the third term, subtract the second term, fourth term, subtract the second. If you do that 3 times, and I would do it at least 3 times, and if the difference is all the same, then you have a common difference, and it very much looks like you have an arithmetic sequence. Okay, then you're going to use that information and some other information, identify the key parts of a sequence. So you're going to identify the first term. So you come back up here and you look, as you read left to right, the first term is 13. How many terms? N represents the number of terms. So in this case, 1, 2, 3, 4, 5. So N is the number of terms in that sequence. And the common difference, well, we already did the repeated subtraction, is -5. So we're going to use that information. And now we only know 5 of the terms, but let's find the 12th term, or we could find the 100th term. That part doesn't matter. This is 12 is going to be the new N, and the D is still the same, and the first term is still the same. So A is our first term, N now is going to be 12, and D is still -5, and here's the explicit formula. The term that you're looking for, A sub N, so we're going to write A sub 12 in a minute, is equal to the first term plus 12 subtract 1, the term that you're looking for, subtract 1 times the common difference. So we're looking for the 12th term, so A sub 12. 13 is our first term in the sequence, and then we're going to add the 12th term, subtract 1, so this will now be 11 times -5, the common difference. So 13 plus 11 times -5, 13 subtract 55 is -42. So if we were to keep going in this sequence, A sub 12 would be -42. And then the next formula is called the recursive, and that's just, well, what do you do? Now that we have the 12th term, let's find the 13th term. Well, here's the formula. You take, if you're looking for the next term, you take the previous term, so this would be A sub 12, and you're just going to add the common difference. So -42 was the 12th term. We're going to add the common difference, which is what we did right here. To find the 13th term, you take the 12th term, -42, plus the common difference, which in this case is -5. So the 13th term in that sequence would have been -47. All right, we're under 4 minutes. Okay, real quick, when the sequence is an expression, not just a number, so here's our first term, x plus 2. Our second term is 2x plus 4, 3x plus 6, etc. So you're going to do the same thing. You're going to do the second term, subtract the first term, the third, subtract the second, the fourth, subtract, and what you get is the common difference of x plus 2. You're going to identify the key parts. A sub 1, well, here's A sub 1, so x plus 2. You're going to find the common difference, which is also x plus 2, and the number of terms. In this case, 1, 2, 3, 4, there are 4 terms. But if we want to find the 8th term, well, you're just going to use that explicit formula. A sub n is equal to A sub 1 plus n minus 1 times the common difference. So here's our A sub 1. Here's our n, eighth term, subtract 1 is 7th term. our difference was x plus 2. So then we just do the math. X plus 2 plus 7 times x plus 2. Well, you do the distributive. So 7x plus 14. And now combine like terms. X plus 7x is 8x. 2 plus 14 is 16. To find this is the 8th term. To find the 9th term, you use the recursive, which is the previous term plus the common difference. So remember, a sub 9 is a sub 8 plus d. So the previous term was 8x plus 16. That was the 8th term, plus the common difference. 8 sub 9, or the 9th term, is 9x plus 18. Okay, this is arithmetic sequence. That's it for this one. Next video will be geometric.